Hi, everybody. This is Ryan, co-founder and CEO of Foam. Really happy to be here as part of these Interchain conversations, and I'm going to be speaking today about the future of radio-based zones on Cosmos. So at Foam, we're working on building the next generation of positioning, navigation, and timing different kinds of infrastructure. More specifically, we specialize in different kinds of blockchain engineering and cryptographic authentication mechanisms across different kinds of radio front ends and unique kinds of hardware and software implementations. Currently, our primary focus is on what we call foam location, which is meant to be a secure and fault-tolerant system that can enable verified location services integrated into Web3 and blockchain-based systems, completely independent of GPS. As we've been working on this project, we have a long history of integrating and building with Tendermint. We see Tendermint as an ideal consensus engine for IoT and hardware-based infrastructure due to its different kind of fault-tolerant processes and proof-of-stake mechanisms. And that's something we've been exploring for a long time, of how these kind of radio nodes can run Tendermint as well as be considered part of a zone within the larger Cosmos ecosystem. Taking a step back from the kind of primary focus of this talk, is just first wanted to also share some aspects of where we've been contributing to the Cosmos ecosystem. And primarily that resulted in a grant and project effort around what we call Kepler, which is a Haskell-based Cosmos SDK. So why were we thinking of building that? Well, one, at Foam, we are a functional programming-based team and primarily work in languages like Haskell, PureScript, or Rust. And we were interested in opening up the more developer languages for the Cosmos ecosystem. From our point of view, we see that as one of the most secure and robust ways to work in statically typed languages. And so in looking at Kepler, the main component is this module component, which can declare a few pieces of information, such as the router module that can be used to process transactions, the router that the module uses to state queries, and the custom effects and interpretation the module introduces. So they're all different kinds of standard libraries that you should be familiar with that you can plug into your application, as well as the option to build your own modules. And you can easily create dependencies between these kinds of systems. And so if your application also has a type, you can use this type to derive all kinds of different useful tools. And so while this is open for the entire Cosmos ecosystem or developers to use, it's the SDK that we're currently building on for our use cases. If you're interested in learning more about Kepler, you can visit kepler.dev, where we have a number of documentations, onboarding information, as well as a sample application around a name service. Hopefully this can help you get started. And if you are interested in developing in Haskell on Cosmos, please reach out to us outside this call. You can join us on the GitHub to open some issues. We also had some recent pull requests of people starting to use this SDK, which is really exciting to see. So as mentioned, we're using that SDK particularly on working on foam location. And so what are these features of foam location? The idea is that it's meant to be an open source standard of a fault-tolerant network of self-synchronizing nodes. In the system, we call an area of coverage a zone of coverage, and each individual radio in the foam language is called a zone anchor. And the idea is that you have multiple of these zone anchors to establish a zone of coverage. And primarily what I'd like to get across in this talk is how we can bridge zones strictly as software connected to a hub in Cosmos to how those zones can translate to actual areas in the physical world. In addition to using these zone anchor radios and open source based hardware, of course, there's also a blockchain component where a zone of these radios would be running a Tendermint chain and been able to enforce the rules of that protocol and essentially the area of coverage that those radios operate on. And kind of the core result and main goal of the foam location system is what we call a presence claim. So how can then a user who interacts with this system and isn't interacting with GPS, or rather GPS isn't even interactive, it's one way, how can they interact with this foam system and generate kind of a cryptographic proof or receipt about their location that was generated independent of GPS and can then be used in different kinds of use cases and applications, almost as a token or an NFT can be used. But these would be specific to location data that could only be generated by being within a zone of coverage. And so this kind of diagram illustrates abstractly these 4 zone anchors that would establish a zone of coverage. Then that zone of coverage would actually be running a Tendermint chain and essentially be connected to the blockchain. So how do we overlap the physical world with the zone infrastructure that Cosmos is so familiar with. And so these zone anchors, and what this zone then would entail, is kind of these entities maintaining a quorum over time and space. And they would be able to then service these customers, kind of illustrated here as this cube moving through. As you enter the physical zone physically, you can then interact with that zone over the blockchain or over radio to generate these proofs. So a little bit under the hood of what all of these kind of zone anchors would be conducting is that they are running this foam location protocol. They have an internet connection to be able to maintain their consensus and run their chain, as well as this low power LoRa radio and a clock and controller. And can move on from this diagram. But something I was thinking about when putting together this talk is, zones are so prevalent as a vocabulary word within Cosmos, but we already kind of have zones in the physical world. You think of words like zoning when we're thinking of urban planning, but kind of more interestingly may also be a free trade zone. And so a zone is kind of something that there are sort of rules and procedures or protocols, and you want it to kind of be contained to a certain zone, let's say, or a certain area. And so when you think about a free trade zone, those have kind of their own rules and processes that are separate from the country or state that they live in, and you kind of isolate that area, and you're looking to kind of enforce those rules in a physical space. And so that's kind of overlapping in our thinking of foam location and how these zone anchors and zones will actually be zones within Cosmos. And so what I mean by that is, looking on the left, we have our kind of standard Cosmos architecture diagram where you have the hub chain, and then you have all these zones, which are unique applications or independent blockchains that all want to kind of scale really quickly and be on their own. And so we're kind of thinking about, what does it mean when one of these zones on the left side of the diagram actually translates to a zone of coverage in the physical world. On the right is one radio that was being tested in a parking lot. There are three others, on the other ends. And so they have a zone of coverage in the physical world, but also would be running blockchain-based software and be considered a zone within Cosmos, and kind of having this new way of looking at what does a zone mean in the blockchain world, when usually that's strictly software-based, and how does that translate into zones in the physical world, and that is something Foam is pursuing. So this diagram is kind of a render where we currently are testing in Brooklyn of what a zone would be, and you have these multiple zone anchors. And so the idea is that in an open source or incentivized way, a zone could form by multiple of these zone anchors kind of running the software, setting that up, and strictly on the Foam side, they would be running location kind of proofs, time synchronization, etc. But there would also be a number of parameters or procedures they would have to go through to be recognized as a zone in terms of the blockchain logic. So for example, do they have the minimum amount of stake? Have they been accepted by the other zone anchors? Have they submitted some sort of proof to be able to admitted to operate this zone? And so to join a zone as a zone anchor, you would have to be proving things both on chain and in the physical world over radio, as well as kind of what your balance is, what your stake is. Are you following the procedures of this protocol? And as I said previously, the end result of a Foam zone is for location services, and how can a customer then interact with this zone in the physical world, but then see kind of on chain the result. And the result in this case is be what we call a presence claim, this digital authenticated receipt that is generated by being in the zone, and kind of shows that you could only have been in the zone to have obtained that presence claim. So looking a bit more specifically on what is a zone anchor in Foam, these devices that together can establish a zone both on chain and in the physical world. Currently, in the way that we're building, they have a low power radio, in our case is called LoRa, an FPGA for digital signal processing. And in the future, as this talk is around the future of zones in Cosmos, a chip-sized atomic clock could be added for more precise timekeeping, as well as a RISC-V open source compute, as opposed to working with something from ARM or Intel. So breaking that down a bit, or what are the components within a zone anchor on Foam? as I mentioned, there's this low power radio. It's kind of been proven in the sense that these radios are being used for just transacting low power radio signals, like for IoT use cases in different areas around the world. What's also interesting about this is it's a license-free band, meaning that anyone could be able to run a low power radio network. It's permissionless in the way that blockchains are meant to be permissionless and anyone could set one up. And so when looking at all the kind of options, this LoRa-based radio fit the kind of criteria of needing something that was accessible and cheap, but also that was permissionless to participate in. There are many developments underway in terms of chip-sized atomic clocks, and we've been speaking to some that are working on those, and they will be coming to market soon. And this will enable a higher degree of performance as well as precision when working on these kinds of use cases. And I spoke a bit about RISC-V. There's a lot of developments that definitely those in the blockchain space would be interested in terms of open source instruction set architectures that can be customized into these kind of domain-specific architectures for one specific use case. This has implications for the foam zone anchor, but also implications generally for hardware, whether that's validation hardware, VDFs, etc. And finally, we have an FPGA within the foam zone anchor, which is meant to perform signal processing. So we have this front-end radio receiver that then calculates timestamps of these incoming packets and can decode these signals. And then we have a software suite running as a software-defined radio that runs the foam location-specific protocol, make sure that all these zone anchors are synchronized across the zone, and can kind of relay time-stamped protocol messages to their local blockchain. Additionally to the work being done on this FPGA around timestamps, it would also contribute to maintaining consensus of how these zone anchors actually can produce or maintain blocks. And this is kind of just a screenshot of some of our experiments of what's actually being registered by this entire zone anchor in terms of radio signal processing. These are our internal dashboards, and they're currently being kind of productized for users and testers who want to eventually join and participate in testing and building out these foam-based zones. So it won't look as intimidating as what you see here. So that's kind of an overview of how we imagine Cosmos kind of zones existing with foam zones. But to have these kind of radio-based zone anchors also be validators on a Cosmos zone, you have a lot of hardware considerations in terms of latency, efficiency, power, and especially if it's a full node trying to validate all of this. So with that, we've been started an initiative we call Soft Foam, which is an FPGA initiative based around Tendermint and Cosmos to kind of bring this hardware performance to the next level so that hardware that's running as a validator on a zone can do so with kind of the reliability and efficiency that you would expect for the years going forward. And so what this initiative is really all about is about building a full Tendermint validator on an FPGA. This is something that can be open source and accelerate hardware accelerated Cosmos client for IoT devices that would be powered by a low power system on chip targeted for FPGAs. What this would give you is kind of energy efficiency, low latency, kind of local data center blockchain where you can think about something like 100 gigabytes with 6.25 nanoseconds in latency. So this soft foam project would enable low power and long range wireless devices to form and participate in a Cosmos network without connecting to an existing internet-based network. This could be thought about in kind of rural communities and may have overlaps with some other projects we've already heard about through this conference, as specifically then to IoT applications. Tendermint, as mentioned, is ideal for IoT use cases, and this soft foam initiative can accelerate development as well as security and performance for IoT-based zones. So kind of a user story would be if you were a developer building a node who wants to join this mesh network, power consumption and timing in terms of wanting nanosecond precision, at least in the localization use case, you can use soft foam as a system on chip in your custom hardware to get these kind of accelerated cryptography guarantees, low latency and power. So this is something we're really excited about and would be considered part of the next generation of the foam zone anchors. So that's how foam location and the future of kind of foam-based zones for location would exist within the Cosmos ecosystem. Something else that we've kind of worked on a bit to show how this developments could be accelerated or made more simple is something called Foam Lite. So Foam Lite doesn't have an FPGA and it doesn't do location-based services, but it serves as a general purpose radio relay node that anyone could build today to connect IoT devices that don't have internet onto different kind of blockchains. The hardware used in a kind of Foam Lite general box is open source, off the shelf and easily accessible, and can be made to be critical infrastructure for all different kinds of blockchain applications. So radio-based zones on Cosmos are not limited to location services. There's an opportunity to accelerate use cases and leverage automation and interoperability of Cosmos by allowing or making known more ways to kind of connect IoT services devices and be able to run basically zones on Cosmos using Tendermint for consensus for all different kinds of use cases. The first use case we explored was around a kind of factory setting where you have a barcode scanner that doesn't have internet connection and is low power, but it could send a message over radio and can do so by signing it cryptographically. So meaning it has an account on the blockchain. So this device is kind of bridging smart contracts into the real world. The Foam Lite node is this gateway device that can listen to these low power messages from these sensors and relay them onto the blockchain for them. And so this is a general purpose design and just kind of looking to show people that you could get started today building zones that are specific for different IoT use cases, and definitely reach out to us if you're interested in doing that specifically for Cosmos or Tendermint, and we can help you. And so thinking of kind of just ways to, make people more aware or get their hands on hardware and definitely take advantage of all of the developments we've been hearing about these 2 days. There are things like parking lot sensors that you could use in terms of building automation, taking advantage of all the kind of new developments, whether it's WASM or Tendermint Rust or just new ways to work with embedded systems. So it could be, and then build applications really quickly. Have we seen it so quick to launch a Cosmos-based zone on blockchain? You could easily integrate IoT devices and kind of build it custom to your use cases or needs. So that could be anything from different kinds of sensors for quality of air or soil, or things like waste management. And hearing from the community, we've heard some interesting ideas around, bringing DeFi as well into IoT. For example, if you had a people tracker counter, could there be some sort of derivative token that traded in price based off of some real world metric? And so the idea around Foam Lite is to kind of show that you can build IoT sensor-based blockchain applications, taking advantage of all what has Cosmos built today and kind of accelerate those use cases much forward. So that's what I had in terms of just showing the overview of what different kinds of future use cases there can be with hardware, and specifically what foam zones mean in relation to Cosmos-based zones. I do see there have been some questions, so I'm going to open those up now and take a look. So first question was if there's an opportunity to find combine foam zone anchors with different kinds of projects such as Altheum or Helium. Yeah, definitely, absolutely. We intend for those to be completely open source in the sense that anyone could assemble their own, and you can essentially add more hardware if you wanted to, in terms of whether that's a Filecoin kind of based or storage-based protocol you want to add into your box, or if that's kind of mesh internet. So there's definitely the opportunity that anyone could be building their own box, and kind of, we say a lot about money Legos. Can you kind of have hardware Legos that work across different protocols? That's definitely possible. Specifically, the FPGA component we would be using would be targeting the location services aspects, but there's a lot of opportunity for someone to build their own kind of generalized box that takes advantage of a lot of different use cases. The next question is, what would be the fees or commissions of interaction with the Foam network as an IoT device? So within the Foam location protocol, there are mining rewards that are meant to incentivize zone creation. And there are different kinds of mechanisms to ensure that coverage kind of expands. So there are ways to signal that you want coverage in a new location. And so that's an initial period where people will be incentivized to kind of build out that service. In terms of fees, zones can be flexible to accept whatever fee they would like for that service. And so each different area may have more traffic or more demand, and be set the price accordingly depending on how many users they have for location services. If you just wanted to build a foam light node and kind of connect IoT sensors to the blockchain or a Cosmos zone, you could define as well your own application, what kind of fees you would want to have, etc. Are you using Haskell to program the FPGA? Example, Clash. Yes, we are building in Clash. We've actually worked with the founders of Clash and made some open source contributions ourselves. I'm not sure I'm able to link it to you now, RV. But yes, we are using Clash, and we have contributed to Clash directly. The next is, does consensus communication between nodes happen over radio or on the internet? So a bit of both, I would say. Consensus over the time synchronization happens over radio, meaning each node can tell without talking to the internet if the other nodes are sending the correct data and if they are in sync. But in terms of then translating that consensus to a blockchain, that is where the internet is needed. So these zone anchors do need an internet connection, but the devices that they are tracking don't need an internet connection, let's say. So how blocks are being produced within a zone, let's say Times Square, you have a zone there in foam, those zone anchors would be connected to the internet and be producing blocks on their zone's Tendermint chain. And we have another question about Haskell providing advantages over other languages. I can directly you to our Kepler blog post where we go into why we use Haskell and why we have what advantages we think we have, as well as some comparisons to other options such as Substrate or Cardano. Definitely reach out either directly or on the Kepler GitHub if you have more conversation questions or etc. The next final question I see is, IBC integrations. Yes, perfect. Thanks for the question, Dean, as well. I think we had a good time last year presenting at an IBC meetup in Berlin. So yes, probably should have had a dedicated slide within my presentation of where IBC plays a role. So I was trying to just get across physical zones. But yes, each individual zone or area of coverage where these radios are will then be their own zone on Cosmos or their own blockchain. So naturally, we want to know how can all this data then interoperate with each other. And so IBC will be key here. We're looking to kind of expand on Kepler to see about working on IBC in Kepler, but otherwise we can use other languages or applications. And another part of the foam location architecture would be kind of a master foam zone or even its own hub that would need to keep track of all the other locations, all the other zones, all of their performance, all of their rewards, and or if there's like some sort of flashing. And so that architecture hasn't been fully defined, but IBC will absolutely be crucial to how this ultimately comes to fruition. Yes, Sunny, they could, or they could go through kind of a, like maybe there's like a city zone or a city hub for that kind of area. So I think that the architecture between zones is still needs to be investigated further, and there's a lot of potential for how that may look. I'll wait another moment if any more questions come in, but I want to thank everybody for their time, attention, and feedback. You can follow me at Froth City on Twitter or Foamspace at Foamspace, and you can find me at Ryan at foam.space if you have any questions or would like to get involved.
Thanks, Ryan. This was great. We're going to transition to our next talk now. Thanks again.
Thank you.